Hello. Yes, good morning. So just confirm that, okay, hello. Okay, so here we are. This is the last day for our courses. And the topic of today is the site analysis, which is very important, and the optimal installation of the network, RFID networks. So maybe before starting, as you know, we will start with the quiz. And before that, as I promised to you, I can show you the tags and some stuff related to RFID. So I don't know if you see that. This is the insert. Inside this package, you have the RFID tag. So this is, and you see the holes. Are you seeing my camera? Okay, so you see the holes in order to fix this box, and this is what we done to tag the PCs, because the laptops and PCs are in metal, and this is UHF RFID. So this is why we are using the plastic insert. Yes, the tag, but inside you have the inlay. This is the insert plus the inlay. This is so you can see the width. You have more than 4 millimeters, maybe 6 millimeters in plastic. But inside you have the tag and the inlay. Okay. Usually we name this the tag, but the true tag, the inlay, is inside, and the waveform come and penetrate the plastic and then read the information. So the tag is like this. I don't know if you are seeing. So this is very thin. This is paper. So in copper you can see the antenna and the IC. Okay, and this is inserted. This is the inlay. You have many types. You have this one. Like a cross. So this is many tags. Okay, I don't know if you are seeing this. So in the middle you can see the IC and the antenna. Okay, you have different type, different shapes, different. This one is circular, for example. No, the paper is not the inlay. This is insert, but it is in paper. The inlay is only the integrated circuit and the antenna. Okay, the round part is the antenna. Here you have the antenna. Let me show you This is the antenna, the circle part. In the middle you have the IC, it's very small, in the center. And this is inlay, this is the paper. Okay, so another one printed. So the ribbon, and you have impression with the printer, and you can see, you can have the barcodes and other information. You see University of Moncton, and maybe I put UPEC too. Can you see UPEC? Université Paris-Est Créteil, University of Moncton. We can print what you want. The barcode, and you can have the RFID. Tag. And this is a ribbon in the printer, and you can print it after writing the information, storing the information, and so on. Is it okay with you? Okay, so I can show you also the handled reader. Yes, this is the handled reader. So here you have the antenna. Here, this side is the antenna, and this is the reader. Okay, and you can send the wave and read, and you have a screen here. Okay, and you can store information, read and write with you, with your device here. And by pushing here, you can read and you have a stylus here. It's touch screen, and you can write information. Okay. And this is fixed reader. This is a real antenna. The cable. You can see the cable. You can see the cable attached to the reader. So here, so this is what type of antenna, just by seeing the shape of antenna? Can you guess? No, coaxial is the cable. The cable is coax cable. But the antenna, the polarization of the antenna. Why vertical? Linear? No. It's square. Square is close to circle. Okay, this is the shape. So the wave go from the center of the antenna. Okay, so attached to the reader, and this is the reader. So you can have connection to the network. Okay. And this is the reader, fixed reader, fixed. Okay, you have you can fix 4 antennas here. 4 antennas. You can read tags with 4 antennas. Okay. This is good to see the device. Any questions? Okay. Okay, good. So now it's the time of truth. Now the quiz. So the quiz for today is here. I think that you can download it from the e-learning platform, right? So you can download it, and you have between 10 and 15 minutes to do the quiz. just without your documents. Please keep them away, please. And just with your knowledge and background, and try to do it. And even if you have a worse score, it's not a problem. It allows you to see what is your level and what are the difficulties. Just tell me if it is okay. You have the quiz. No, maybe no. Oh no, okay. So let's go to the live e-learning. Okay, maybe not. Sorry. Okay. So documents. Okay. So I make it available for you with the slides of today. Okay, so from now you have 12 to 15 minutes. Good. Time for me to bring the coffee. You have the quiz, huh? I didn't give you. I gave you the right document, right? Okay, just confirm. Okay. Okay, Mohammed, thank you. Okay, hello. Yes, we already started the quiz, so you can do it, Sixtus. And if guys, if anyone has finished the quiz, so just text that you have finished. Okay, you can do it, but we are close to the end time of the quiz, Sixtus, but you can start to do it and try to answer. Okay, Mohammed, Lisa, did you finish or you need 2-3 minutes more? I mean, okay, so 4 minutes, 4 or 5 minutes remaining. 4 or 5 minutes remaining. Seeing only 2 here. What do you mean, Sixtus? You mean the quiz? Okay, so yes, the see on the e-learning platform. The e-learning platform, just let me check. Okay, you have quiz 3, quiz 3, 2000. Okay, so maybe users. Let me check your name. Are you here? Yes. So in the documents. Got it, Sixtus? Did you got the quiz on the e-learning platform? Quiz 3? Okay, so check and okay, Hino. Anyone else finished the quiz? I don't know if you agree with me, but done for you, okay, Theo. But the difficulty increases day from a day to another, huh? Right? So if we continue our courses, maybe the fourth and fifth quiz will be very difficult. Huh? Today is difficult, okay. Okay, six is yeah, no problem. So I think that that the university explained to me that it is possible to follow the course offline, right? Okay, because we are recording the course and so on. So for me, it's not a problem. So you can do it, but just try to do it without seeing anything. So do your lecture, and then after that, do the quiz without by keeping away your documents. So just follow exactly the same rules as your teammates. Okay, so 1 minute remaining. Okay, guys. So Lisa, is it done? Mustafa. Mohammed is done. Okay, is finished. Theo is done. Okay, so let's start with the correction. Do you need 1 minute more, or is it okay? Can we start the correction? Okay, good. So for the first question, France is included in which of the following regulatory regions for RFID? A. Yes, A. Air Interface Protocol defines rules for all of the following except communication between reader and tag, bit encoding and decoding, commands for reading and writing to tags, formatting EPC numbers. Hina D, Lisa D, Amin D. Should I go with the majority? Should I go with the majority? Any other response? Okay, just guys, I have an urgent call, so just let me answer the call and I will be with you. Okay, sorry, because I received an urgent call from my home, so just it's okay. Sorry, so I have 10 minutes or 12 minutes or 15 minutes to add after the okay. So I hope that everyone is still here. Okay, still connected. Okay, it happens. Okay. So yes, okay. So for the second, where the question is D, so I will go with the majority. For the third question, all of the following are elements of EPC global network except which one? Yes, Lisa, B. DHCP is for computing, and it's to allocate dynamically the IP. Okay, so for the persons who are aware about computers. Okay, so good. So in the test, usually be aware about except. Okay, so except it means the false, because when we are reading rapidly, sometimes we missed this word. So be aware about except. When UHF tag orientation is known as and remains the same, which of the following antenna provide the longest read range? So here you have four. Yes, good, very good. Okay, C. Yes, you are good today. Yes, C. And can you explain to me why it is C? Just in few words. So it's clear between C and D. It is C. Okay, then D is eliminated. Okay, between C and D it's clear. Yes, because we have more GAN between C and D. So D is eliminated. Now, maybe between these three, I have one linear and two circular. Okay, so the question is 8 dB can beat the 9 and 10. Yes, this is why when you are circular, you have a good covering, but a less read range. This is why if you want to have a good directivity, and you can choose linear. So because we know that the tags are remaining in the same place, so it is safe. It is safe. It is safe to take a linear antenna. Okay, because the orientation of the tags is the same. Okay, because the orientation remains the same. Yes. This is the rationale about this. Good. Okay. HF RFID systems communicates using which of the following type of coupling? HF RFID, which is the communication method. Mohammed CE, Nina CB. Other answers? Amin E, Lisa D. Should I go with the majority in other answers? Just to balance something. Lisa is right. Yes, it's D, because you are in HF. HF is high frequency, but it's still using the coils and magnetic. Okay, so low frequency and high frequency use inductive coupling. Okay, so keep this in mind. It's very important. So backscattering is used by UHF and microwave. It's very simple. So you have 2 and 2. 2 for inductive coupling, and because you are in low frequency, it is not possible to use the radar process, because you cannot have the scattering of the waves when you are in low frequency. So this is why we are using magnetic communication. Okay, so D here. So you are in the process of designing a closed loop asset tracking RFID system. Which of the following standards must be met? So the first one, second one, third one, fourth one. Okay, Hina Mohammed, yes, B. Another answers. Other answers, please. If you have a doubt or. Okay, just tell me. Okay, Amin is for B. Lisa for B. Okay. Okay, so I will go with the majority. Yes, B, because we are in closed loop. Okay, closed loop. It's not mandatory to follow a standard. Okay, here, which of the following standards governs the HFR interface between tags and readers? Remember, I gave you the slide yesterday. I gave you the slides. So, is it B? Is it E? Is it C? Is it D? Me too. I am not good on this, but if it is better to do the lecture. Okay, because it's written on the slide. Hina say A. Lisa, many B's. Yes, we have only one B, Lisa. But unfortunately, it's not the right answer. Yes, the right answer is E. Okay, so just remember S. Right, E, yeah? Yes, yes. Yes, I mean, yes, it's 3. We will check in the yesterday course because I give all the. So the HF is 3. Yeah. So on a factory floor, conveyor belt is moving boxes. Tags on the boxes are always on the same side and have the same orientation. The boxes are to be read by an interrogator before they are sent to different conveyors. Which type of antenna provides the best performance? Linear polarized, circularly polarized, isotropic, non-polarized. Yes, good, linear, yes, because we know the place of the tags. In a distribution center, there is 20 dock doors in a row. The interrogators at some dock doors are reading tags passing through the adjacent dock doors. Which of the following actions should be taken to solve this problem? So there is a problem because we are reading from other doors. So the response here, yes, A with a majority. So installing shields, yes. Hina, shield interrogators does not give any impact because the interrogator, the readers. So I show you in the camera. You have the reader here. Okay, you have the reader, and you have the antenna. This is circular antenna. Okay, you have the reader. If you shield the reader, it means that you put a Faraday cage. Okay, here you can isolate the reader, but the reader does not emit anything. This is the antenna which emits the waves. Okay, so when you shield the antenna because the wave the output of the wave is from the antenna. Okay, so shielding the interrogator will not be effective. Okay, Okay, Hin. This is a classical question to in the professional exam. Okay, so when we shield between adjacent doors. It means that certainly we will shield the antennas, because replacing the interrogators, it's not a solution, a realistic solution. Use antenna with higher gain. It's not a solution to, because you still have the problem, because the reader are reading the tags of other doors. Okay. So shielding is the best solution. So for 10, which of the following is not a consideration when selecting antennas for RFIDs? Antenna gain, antenna frequency, antenna protocol, antenna polarization. Mohammed C, C, Hina C, Lisa C. Oh, you are good today. Yes, I can confirm. Yes, C. C, because it means nothing, protocol of antenna. We have a frequency for the antenna, the gain for antenna, the polarization for antenna, but protocol, we don't know protocol for antenna. So 11, in a portal installation, the length of the reading zone is not long enough to read all the tags, while the forklift is carrying the goods. Only 80% of the tags are read. Which of the following is the best solution to read all the tags? Install 2 antenna above one. Decrease the interrogator power. Install 2 antennas side by side in such a way that their combined zone is longer along the direction of travel of the forklift. Yes, this is C. Yes, C. C. Use an antenna with a higher gain. Okay, so C is the best solution, because we covering the region where the forklift travels. In a warehouse, there are 60 UHF Gen 2 interrogators operating. Which of the following configuration parameters must be set to the same way for all the interrogators? For this, you set the interrogators to multi-reader mode. Set the read drive to 3 for all the interrogators. Set all the interrogator power levels to 50%. Set all the interrogators to dense reader mode. Yes, give me your answer. C? No, it's not for this question. Huh? For this question, what? Just guess if you don't know. I know that this is maybe D, Mohammed, because when you, if you are in a real situation where you have to do the exam, maybe you will have situation, unseen situation. You didn't see this situation before, but you have to use your logic to. Yes, you are right, Mohammed. D is the right answer, because in modern and the recent readers, we have the configuration of dense reader mode. So you have algorithms that manage the fact that there is overlapping between frequency and so on. And there is a point here. You have 60 UHF Gen 2. If you are operating in France, for example, you have how many channels? Maybe there is a question after that, but 60 is very huge number, even in US or in France and Europe, because the number of channels is less than 60. Okay, so you are in a situation more readers than channels. Okay, so you are in a situation where you are in dense reader mode. Okay, so just by seeing the number of readers. So even if you are in US or in France, you have more readers than channels, than available channels. Okay, you are good with the explanation. Just say me yes or no if you have questions. Okay. So we do quiz, but in same time we do like lecture, like okay, it's not just giving the answers. So we explain, we give the rationale. Yeah. This is why it's a kind of course or also, and it will give you the logic behind the questions and so on. Okay. Okay. And in same time, it prepare you if you want to spend $400 for the official certification, you can do it in good conditions, preparation conditions. So 13, which of the following statements describes a Faraday cage? I think Mustafa or Mohammed asked me the question yesterday, but about the Faraday cage. Is it a kind of installation to do or something like that, or material? So here there is a question. So a Faraday cage is a metal box used to store RFID chips, yes, chip tags. A Faraday cage is a tunnel-like structure made of conductive material and placed around the antennas. A Faraday cage is a box placed around the interrogator to eliminate electrostatic discharge from the interrogator. A Faraday cage is a box placed around the interrogator to protect it from the environmental hazards. Okay, so what is your answer? Yes. Other answers? Are you still here with us? Okay, Mohammed D. Lisa A. Yes, D for Theo. Yeah, yes, I already explained that it's not efficient to place the Faraday cage around the interrogator because it doesn't give anything, any impact. So the Faraday cage is a tunnel-like structure which is made of conductive material and placed around the antennas. Okay, this is the right definition. So you can maybe write it in your notes and your documents. This is the right answer and the right definition for a Faraday cage. Okay, so B is the right answer. Okay, the maximum RFID power. This is an exercise for your memory because I gave the number yesterday somewhere in the slides. The maximum RFID power allowed in Europe is A, B, C, D, 3, 2, 2, and 4. Difference between B and C, this is effective isotropic radiated power, and for C, it is effective radiated power in Europe. Yes, Lisa, C. Yes, C. 2 watt, but what which 2 watts? I mean, B or C? No, B. It means that for Europe, the regulation is 2 watts ERP. Okay, it's not the same. 2 watt ERP, it means that you can multiply this by 1.6 to have ERP, but the regulation is 2 watt ERP. Yes, Annie. So this is C. So just see your documents for that. Okay, maybe even me, maybe but this is C, the correct answer. I'm confident in my memory, but just be sure about that.
I gave it in the slide yesterday. The standard for the container, freight container identification is which one? Classical question 2. Yes, A, ISO 10374. Okay. The GS1 organization. So 15 is A. Okay. Okay, everybody. Yes, 15 is A, and you can see this in your document too. The GS1 organization resulted from the unification of EPC Global and EAN, UCC and EAN, ISO and IEC, ERAN and IEC. So which is the right answer here? Yes, B, UCC and EAN. Yes, B is the right answer. Okay, which of the following statements about object naming service is true? The ONS system returns the IP address of EPC discovery service. The server which provide this service, the ONS is a DNS server. The ONS provides DHCP for RFID tags. The ONS is the Internet Protocol. Yes, A is the right answer. Yes. Yes. Yes, the right answer is A. So for 18, USA and Canada belong to the following ITU region. 1, 2, 3, 4. Yes, B, region 2. 19, you have a new UHF RFID system with 30 reader working in US. You have collected reader numerous failure data when reading the tags. What is the best action to do to improve the reading success? Increase the difference between the frequency of the channels used by the reader, reduce the reader's power, reduce the number of readers, reduce the number of tags. Mohammed CA, Hena CA. Yes, you are right. A, because we cannot reduce the reader's power. If you have you have a failure in reading, if you reduce the power, maybe you will be more failures. So the number of readers is here. You cannot change the number of reader because you have applications improve. We can improve by reducing too, Hassan. We can improve by reducing. You can improve your budget by reducing your expense, for example. But here it's not the case. You can improve many things by reducing some things. Okay. Reduce the number of tags, not okay. So A is the right answer. This means that if you have this, just to explain, you have the channels. Maybe in US, it means that you have 902, for example, megahertz, and you have these channels. Remember, the range of the frequency band is about 20 kilohertz, 20 or 500 or 200 of. So if you put a reader working here and the reader working in this frequency and the reader, and you have 50 channels in US. So instead of putting all the readers close to each other, it's better, for example, to not use a reader here, but to do it here, and then you increase the probability of success reads, and you use the 50 all the 50 channels because you have only 30 readers. This is the rationale about this answer. Okay, European UHF RFID range contains, yes, Elisa, C. So C is the right answer. Okay. So who obtained 20? 20 on 20. Even me, I cannot obtain 20. So there is no one, huh? Okay. Predictable, okay. 19. Hassan, 90. Today was a bit difficult, yeah, I know. And okay, 19, 18, 17, 16, 15, 14, no, 14 Hassan, okay, 15, so the average is 13, 12, okay, Mohammed, okay, not below 10, just, okay, these are 14. Oh, thank you for sharing your scores with everyone. It's very, here in Canada, it's not possible to speak about scores in public. It's very private. So this is I'm asking for your scores because I'm seeing that everyone can share it, his or her score. So it's I am very grateful for you to share this information with us. But it's good if you are between 10 and between 12 and 14 for this test. It's good. So have just okay. Yes, somehow yes, quite difficult. But so yes, let's start. Any other comments? Okay. Okay, so site analysis and optimal installation. The outline is as follows. Why do we perform a site analysis? Information gathering, interferences and electromagnetic mapping, installation and radiation pattern, RFID blueprint, the network design, equipment selection, RNC and SLRRP protocol for readers, RFID network security, just briefly, and architecture of a global RFID solution. We saw that yesterday. EPC Global is the platform for that, for Internet of Things. Okay, site analysis. It is required to prepare the RFID design phase. It is very important to prepare your project before setting up the network. If you are dealing with a company, you do not miss your project, because if you miss your project, it's for you, it's not good, because it's business with a company. So the company want to improve its business flow and business process, and by using RFID, the company wants to have a good return on investment. Return on investment. It means that if the company spend money to set up an RFID network, it is reasonably it expect benefit from that investment. So this is what we call the return on investment in a short time. not to wait for 4 or 5 or 10 years to have a return on this investment. So this is why it's very important to prepare the RFID design. Okay. If on the site you have many interferences, it's not good for the RFID devices. So you have to check if you have interferences, especially if you are working with UHF, and maybe 80% of the applications are UHF. Okay, please zoom out. These are okay. Is it good now? I think 125 is good. Okay. So for maintenance purposes, and in order to detect and resolve problems, it is also important to have a plan, to have documents, to document everything. So it is a required step. So the first step is to gather information about the organization, about the company where you will set up your RFID network. So it is mandatory to know the business process and the daily operations using the RFID network. Is it for inventory? Is it for shipping? Is it for order picking? Is it? So you have the process of the company, and you should know everything about the process. Who did what? And who do what? Who does what? Okay, so this is very important. The information should be gathered when the maximum load of operations is reached. When you go to the company and you want to set up the RFID networks, you do not go, for example, the weekend, on the weekend, or in okay, or in summer and holidays, because you cannot have the reality of the operations. So you have to gather the operations when the company is at its maximum of working of operations. Okay, very important. So the better is to go 1 week and to see every day, including the weekends, what is happening, to observe. It is important to outline a flow chart and to for the process. So especially if you want, for example, a shipping in-out application, so you have to outline the main operations and the human interventions and so on. So the information gathering is very important. The interference impact. So you have to determine the ambient electromagnetic noise, what we call AEN. This is very important because this is will help you to prevent the noise, prevent the interferences. Okay, so you have to measure the level of the noise. Remember the signal to noise ratio with decibel, dB. This is very important. It could be from Wi-Fi network or telecommunications and so on. Emitting machines. So the electromagnetic noise is composed of unwanted interfering signals. This is unwanted, okay? Unwanted signals. We do not want these signals in RFID. To do that, you need a spectrum analyzer. Spectrum analyzer is an instrument capable of measuring the ambient electromagnetic noise. Spectrum analyzer, as its name indicates, it's a device that will help you to see all the frequency and the level of the frequency in that frequency, the level of energy in that frequency. You know that you will work at, for example, 902 megahertz, and if you notice that you have many noise in that frequency, this can be observed by using the spectrum analyzer. Okay, so it's a very important device. You can just book it, or you can also buy it, but it's required to do analysis using the spectrum analyzer. I will show you a picture of this device. It is also important to perform a site survey in order to identify the potential sources of interferences. So the spectrum analyzer, this is this device, and here you can see the screen, and the most popular is the Bumblebee RFID, and I have here the this is a RFID spectrum analyzer, and supports the RFID frequencies, the Wi-Fi frequencies, and industrial, scientific, and medical frequencies, and Bluetooth frequencies. So it's multiple purposes, and you have the frequency here. So calibrated spectrum analyzing all-in-one system. The handheld receiver measures the popular wireless RFID frequency bands from 860 to 960 and the microwave RFID. So you can scan, display, and record multiple radio frequency waveforms. So here you have the waveforms, and if you in the x-axis you can have the frequency, and in the y-axis you can have the level of the energy, or the level of these waves. So if you have a very high amplitude, it means that this component exists in your site, and then if it is your RFID component, it's okay. But if it is in the same frequency, you have I don't know, a level of a signal which is very important, and it is in the channels, you can choose another channel for your RFID, or you can find a way to remove this interference. This is why the spectrum analyzer is very important to check your site. Okay, so here you have the standards. Okay, and in the y-axis, this is the energy, the amplitude, the level of the wave. It could be in dB. Okay, it's the power in dB. Okay, Lisa. Okay, so here you have the characteristics, the specs of the device. So in dB you have the amplitude and the batteries and the frequencies, and so you can go until 50 kilohertz steps as bandwidth. So very good device. Okay. So you can see the Wi-Fi, you can see everything on this, and you can output a document in a JPEG format. Besides this, you have to do the wireless side, because now you have access points everywhere, so you have to perform the wireless site survey by launching this software, and even by using laptop with the Wi-Fi card, it's possible to map all the sources of and the access point. Here you have an access point, here you have an access point, and this is the energy of the signals, the Wi-Fi signal. So this, for example, this software, which is called Ekahau, is used to perform this mapping. And this will give you a rapid overview of the problematic zone. If you have your RFID source here, it's problematic. Okay, or here, close to the access point, and close to, maybe you can choose or to do some actions to prevent these problems. Okay, and you can discuss with the manager, with the IT manager, to change something. And but if you are informed, it is good, but it's not go like a blind person to do the RFID and without knowing anything about the networks that are present here. Okay, so it is mandatory to identify the source of ambient electromagnetic noise, to perform the analysis by keeping all machine running. It's very important if you are in warehouse or in company where there are a machine, you have to run the machines, because when with noise, with the electrostatic charge and so on, you can have interferences. So this is important to have these machines running, to have the real situation. So as we said before, you have to perform the analysis during a complete business day, business cycle, and to perform the mapping of the electromagnetic wave, all mappings. So you can use the shields, okay, bouclier, Faraday cage, and so on. You have to observe the strength and the frequency of existing signals, thanks to the mappings, and also to prevent the electrostatic interferences, so to systematically put the ground on all equipment. Mise à la terre, okay, put to ground. It's very important to discharge, to put the charge into the ground. And you can use filters. If you have here, you have the waves here. Maybe I can show you it. Here, for example, you can use a filter here to filter this zone. For example, a filter is an electronic device that help you to remove some components. So for some channels, you can use a filter, and then you can use your RFID in that zones. So I can remove this zone, for example, by using a band pass filter here. If I use a band pass filter here, I can use this frequency for RFID. So this is many ways to avoid interferences. So the grounding is very important. This is why I repeat here, the grounding is very important. It minimizes the interferences, it reduces the risk of damages, it eliminates the electrostatics effects, and protect the personnel, of course. So this is very important. And the most important thing in grounding is to use a common and unique grounding. I underline this, it's very important. Very important. I underline twice. Very important. Unique, common. So you have access point for Wi-Fi, you have machines, and you have RFID here. Reader, you have tags, you have antennas. Okay, and you come to the company and you ground your reader and your device. It's okay. And this access point and so on, Wi-Fi devices are grounded, because when they are power on, there is a ground. Okay, but it's not, this is not grounding. This is not an effective grounding, because you have two different ground. You have to connect this grounding with this grounding to be effective. This is a common ground. in order to have the full benefit of the grounding. Okay. Okay. So if you have a configuration where you are using a portal installation, so that your system requires a minimum power because you are far from the computers, far from, this is a portal, maybe it could be outside the company. So you have to ensure that the read zone is covered by 2 antennas or more. The radiation pattern is highly directional because you have a portal, so it is directional. In the case of contiguous portals, take care of possible ghost reading, and to prevent this, you know that we can shield, we can remove the interferences too, and raise the antennas to prevent the shock. The antennas should be away from the users. Okay. So you have to determine the radiation pattern. It's when you start your site analysis, it's important to determine the radiation pattern. Of course, when you buy the antennas and so on, when you buy antennas, the sellers will give you the theoretical radiation pattern, but it's not the real radiation pattern. So you have to perform a mapping of your antennas. You open your reader, you open your stuff, and then you observe. You make readings. Remember, in the when I showed you the experiments we have done with water and metallic. So we perform multiple readings, and we can see where are the best places for the readings. So to define the real radiation pattern, we place each tag at a constant distance from the center of the antenna, because the center of antenna, this is output of the waves. We put the tag, okay, this is the main lobe. If it is very directive, maybe horizontal polarization, and then we perform the readings. So we put the reader at its full autolazide power, and then we record the number of readings and divide it by the number of lecture attempts. If I do reading maybe 100 readings, then if I do 100 readings and I have 100 reading in my computer, successful readings, it means that I have 100% of reading. So this is why we have to perform this division, so to have the reading rate. And then we move our tags, we put our tags everywhere, and I can define the geographical shape of my radiation pattern. So the shape will be defined. Maybe it could be this way. Instead of this perfect shape, it could be like this. Okay, instead of that. And here maybe it could be like the side lobe, maybe this way. Okay, this is the reality. And this is important to measure because this is a reality. We will be, you will face the reality. Okay. Test the radiation patterns close to a metal or a liquid UHF. When you are in UHF, if you are in warehouse, sure, maybe with probability close to 1 that you will have to deal with water and and metallic objects. So this is important to test your tags. Are they protected? If you are using these tags, maybe there is no problem for water and metallic object. But if you are using maybe more thin than this, or maybe these tags, for example, with paper. So these tags. Because here what we can do, I can show you it's good to show you. So I will use the one with UPEC, Université Paris Créteil, okay, partner. So I will show you. Seeing this. So is it good? Just I will do experiment with you and just tell me if it is good. Okay. Because this is UHF. I don't know if you see I printed this. Okay, I can use I can use the barcodes or the RFID. This is print. This is paper inlay. Okay, so I will do something. Okay, I will take. Imagine that. Okay, what I can. I have a laptop, metallic laptop. I will bring it to you. I want to tag this laptop. Okay, the cover is metallic cover. Okay, I will take my tags. My tag. There is the tag. Okay, there is the tag, and there is my object. UHF. So see what I can do, because it is, I can stamp it. So just to see here, I remove this. So it is from the printer. Okay, so see what I am doing. Okay, and this is to the trash, and this is the real tag, and here it's glued. Okay, I can put it here. Okay, so I put it in my here, for example. Okay, so I have my object, and then there is antenna UHF 10 meters. I can, so it doesn't matter if I have a line of sight or not. And I have the reader here. The reader is here, and the reader is connected to the computer. And then normally I will, if I take away with the laptop, I can have a message on my computer that the laptop left the room. Okay, but is it right what I'm done? Remember, I worked with UHF. This is UHF tag. Okay. So you can see the tag. No. Okay. Why? Yes, it is very close to the metal. Yes, it's not. You will 0 success reading. 0. You will not. Yes. So this is why it's better to use this. This is to use this. Okay. To glue it, or to find a way to put this, if you want to follow this item. Okay, so we lost one. Okay, so this is why we step to follow, place each variable from the metallic object and from a liquid, and see the what you will. But with this experiment, sure that it will be not correct. But even by using these tags, you have to perform the test. Okay, but because the reality will speak, there is nothing better than the reality. Okay, even if you have theoretical spec and so on. And you have to provide a report on the optimal readings. Okay. So you have to plan for the RF signal coverage. You inspect the site, establish a plan of the site, describe the site and the activity zone, identify the optimal positions of the antennas by avoiding the interferences and by achieving the objectives of the targeted application. So you discuss with the manager, with the IT, with the users, and about the application. Is it portal application or just localization application, and so on. Perform a mapping of useful electromagnetic field. Identify the zones of maximal, medium, and low coverage. So this is the mapping. And document and update the information. And to do that, you can use the blueprint. What is a blueprint? Blueprint, you have after installation the antenna in expected position. You use a spectrum analyzer, which draft, yes, like a draft, and croquis, and plan. Use a spectrum analyzer, which determines the power of the frequency used. Note sum of nominal power at different distances from the antenna. So you can put dB, for example, you can be at 10 meters and you have minus 2 dBs. You note this on the blueprint. Once the furthest point of an optimal reception obtained, we can mark it. Repeat step 1 to 4 to cover the whole working area. If more antennas are needed, make sure that the adjacent antennas have their diagram working in complementarity. Very important. Common sense. So there is symbols for the blueprints. For example, this is the symbol for electrical outlet with 110 volt. You know that in US and Canada there is the nominal voltage in houses, domestic voltage. And this is the three phases voltage in US and Canada, but this is the regular voltage in Europe and France. So there is the electrical outlet with 3 phases, the ceiling light, the wall mounted light. It's very important. Even lights are very important. So the network outlet, the telephone outlet, and the switch light. This is symbols. So an example of blueprint is like this. Here you have your antennas, and then okay, 3. This is your RFID antenna. 2 is spectrum analyzer, maybe just to see that we perform the radiation pattern. Okay, so this is a blueprint. This is metallic H-beam. This is I-beam or H-beam. It's metallic, so it's important to. So this is an example of blueprint. RFID network design. It is important to identify your objectives and constraints to convert your utilization case into technological requirements. You have to put a list of your equipments and the specs of your equipments and so on to develop the applications scenario. Make the right choice of adequate equipment. So for the tags, making the right choice for every device in your RFID network is what we speak about now. So maybe we can take 10 minutes for break, okay? Are you agree for the break? 10 minutes? Okay, 10 minutes break, guys. And we will be back. Okay. Okay, so let's continue with that. So for the tags, you have to be sure about the robustness. As I show you, for example, if you have this type of tags, for example, it is more robust than this. So depending on the application and the use of the tags, so you have to be sure about the robustness, the reading distance, and the tag antenna design, the density of tags. So as I told you, there is some, for example, if you take this, you have many tags, and here the distance is respected. But if you, for example, put these tags this way, you have two tags that are very close. So this is not good because you will miss the readings, and maybe for the two tags, because you have to respect the 12 millimeters and 25 millimeters distance between the tags. So as we saw, the orientation of the tags is very important, and the movement of the tags are very important. This is a very important definition, the dwell time. So this is very important, and you have to memorize that. The dwell time is defined as the duration time during which the tag remains in a readings area. For example, if you have a configuration where you have a moving inside and outside the portal, where you have the reader and you have the antenna here. Okay, so maybe the covering zone is this. So if you are moving, you have a tag here and here and here. Your tag is moving this way. Okay, so the time spent in this movement is called the dwell time. This is the duration time during which the tag remains in the reading area. Okay, it's very important because in engineering and in your planification, you can estimate and make a planification according to the dwell time. Okay, and then of course you have to define the information that will be written into the tag and made available throughout the network. Okay, this is very important. There is tools for optimize the labeling. For example, there is hotspot tool, which is widely used to optimize the RFID tagging. So the EPC hotspot, manually you can determine the good zones for stamping your tag, for putting your tags, and you can use the applicators and the printer and to do automatic and semi-automatic labeling of these boxes. So you have the palette, and you have the top of the palette and the left and the bottom, the front of the palette, and then you have the position of the antennas and so on, and you have the type of material you are transporting and so on. So the hotspot EPC can just by entering the informations, you can have, and the hotspot will provide to you the zones where it is preferable to have the tags. So green zones are better than red zones. This is just an example. Okay, if you are using UHF and transporting liquids and so on, so with these palettes you can have a cartography or mapping of the zone that are good for stamping tags. The readers. As you know, the readers are handled, embedded, or fixed. Upgrade capabilities, so choose the readers that are capable of extensions. There is a protocol that allows you to manage and to do administration of the readers thanks to a protocol which is called the Sample Network Management Protocol, like for computers and computer networks. SNMP, it's an Internet Standard Protocol for managing device on IP networks. Okay, you can access to the readers and then you can manage these readers, same as in a computer network. Also, you can select more robust, so more expensive readers depending on the applications and the movement of the readers, of using of the readers, and so on. The quantity is very important. And as we saw, the cable should be maintained at the minimum distance between the readers and the antennas, because you have the cable loss, remember. Huh? For the antennas, you have to select depending on the polarization, and the number and distribution are defined by the blueprint. And if you can do the mix of circular and linear polarization and choose the adequate impedance for cable, and this is very easy to respect. The cable very important thing. So because you are using the thin cable, this like this one, this is a thin cable. Okay, there is a thin coaxial cable. Okay, this is a thin, so this is the coaxial cable. But you have the connector here, but if you want to reduce the length of the cable, you have to cut it. And if you cut the cable, you cannot cut just arbitrarily. Okay, they're very important. So if you have a cut, you have to be sure that you respect the rule of multiple of wavelength or half wavelength in order to minimize the attenuation and the reflection. This is very important, and usually installators, human installators miss this rule, and this is why they will obtain a very bad network, very bad connection, just because this non-respect of this rule. How we can calculate it? Very easy to calculate. Yes, there is question. Yeah, maybe there is yeah, not all instructors are professionals, so you can have yes, so you're cutting without calculating that. So you have the frequency, the use of frequency, maybe this frequency, and you how you can determine the lambda? Could you tell me? Could you tell me how you can calculate? Yes, yes, and then you have the this is C3. You use this formula, and then lambda is equal C on the frequency divided by 9, 1, 5, 10, 6 hertz. You have to have the frequency, so here you will have 2, So it will be approximately 300 on 900, and this will give 0.3 meter, which is 52 centimeters. So if you cut your cable, you should have it multiple of 32.7. So the multiple twice or 3 times or 4 times, but it should the distance or the length will be close to a multiple of this value. Is it okay? Okay with that? Okay, good. So the checklist for the site survey. Radio frequency site survey, installation and tuning, reader synchronization, cable management, tag design and positioning, device management, and data management. So this is what we have to do. The environment is very important. If you have humidity, it's very important. If you have condensation, it's very important. Because condensation and humidity, this means that you will have water and sometimes water, even in summer. So it's very important to be aware about that. The safety, enclosures and shields protect equipment from damage and safeguard the people who work nearby. So should be very good to ensure the safety for humans and for the equipment. Regulations, you have to respect the country and the organization and regulations. Now to monitor the troubleshootings, many and various factors can affect the effectiveness of reading tags within the interrogation zone. And some quantitative parameters are used to measure the reliability of the RFID system. We will see some of these parameters when events such as reader failure or unread tags occur. So the first one is the mean time between failures, which is the universal parameter used to determine the effectiveness of devices and so on. So the mean time between failures is the average between 2 consecutive failures of a device or a system. It measures the reliability, robustness, and stability of the system. After past observations, it is used to predict the rate of failures. It is calculated simply by this formula. MTBF is equal to the total lifetime of the device divided by the number of failures recorded. Okay, so we will see an example later with this. I give you exercise with this because maybe in the test we can give you a quiz and you have many values to choose, and then you have to select the right MTBF after giving you the information about the failures. Okay, so I will see exactly similar exercise for that. ATTV, which is average tag traffic volume. ATTV is the average number of tags passing through an interrogation zone during an interval of time. The interval could be 1 minute, 10 minutes, an hour. So you can have the average traffic, the average of the traffic. It indicates the load, if you are overloaded or not, how much load the reader has to deal with. To measure ATTV, the tag counts and the time at which the tag was counted are considered. This is simply determined by this formula. So ATTV is equal to the sum of the time and the tags, of the tags in this interval, and we sum all the intervals, and then we divided this by the number of intervals. If it is hours, maybe in one day it will be 24, and this will be for each hour the number of tags by hour, and then we will have an average by hour. Okay, very easy to calculate. We will see also an example later. the read errors to total reads rate, RETR. RETR is the total number of read errors divided by the total number of read attempts. The problem that can cause the read error is include faulty antennas, faulty tags and improperly tagged item, improper placement of antennas, low level of the signal strength, signal interference absorption, and so on. So to measure this, we use this parameter, which is the read error to total reads read. So this is calculated as follows. So RETR needs information about the number of read errors, number of successful reads, and time interval during which the read attempts were made. So the formula is here. This is the number of errors during an interval divided by the total number of errors and during these intervals and the number of successful reads. Okay, this will give you a ratio that is important because so of course the high value of errors should be taken into as an alarm because you have errors here. If you have this value very high, it's not good, and this value can change over time. So we have these parameters to deal with in order to measure the quality of our network. So when you set up your network, you can just document these parameters. Let's do just an example. You have an RFID system with 10 readers. I will let you to do this by using this formula. Okay, I give you 5 minutes to do that. This calculus, just applying the formulas for this case 1 and case 2. Okay, so just let's read it together, and then I will let you to do 5 minutes just applying the formulas in order to see if you are understood. You have a RFID system with 100 readers. You have collected reader failure data for 200 hours. During this time, you have 10 readers that failed once and another set of 5 readers that failed twice. What is the MBTF, mean between failures of this system? This is the first case. Okay, I want to calculate the MBTF of this network, and you have this data. Just apply the formula of MBTF. MBTF is here, is TL on NF. TL is the total lifetime of the device over which the MBTF is measured, and NF is the total number of failures recorded. Very easy. Okay, so this one. So just calculate 1-2 minutes. So you have to calculate the total lifetime and then to divide it by the number of failures. MBTF 10, okay, for Muhammad. How we can, so, okay, anyone else to give us the Okay, so there is a yes, maybe okay, divide. The this part is okay. So you have okay. Let's calculate for the MBTF the lifetime, the global lifetime for all devices. You have how many readers? Muhammad, you didn't have only 5 and 10 readers. How many readers in total you have? Yes. So the lifetime of all the network, it is how many? How much the lifetime is? If you have 100 readers and 200 hours. Yes, multiplied by you have to multiply all the readers by all. Yes, 20,000, 20,000, 20,000. Yes, 20,000. And then how many fillers you got? How many fillers you got? You have 10 that fails once, so it is 10, and 5 that failed twice. 5 readers failed twice, it means that you have 10 failures plus 10 failures, it will give you 20. Yes. So the lifetime, total lifetime, it is equal to 200 hours multiplied by the 100 readers. Okay. The number of fillers, you have 10 readers once, it means that 10 plus 5 readers failed twice. 5 multiplied by 2 will give you 10 failures too. So you have 20. So the MBTF for this is, yes, is 1000 hour by failures, between failures, or this is hours per failure. Okay, this is yes, 1000. Is it okay? Okay, very easy. So if you have less failures, you will have a better MBTF. Okay, now let's calculate the ATTV. Assume that you determine the intervals to be 5 minutes, 15 minutes, and you collect the data over an hour. In the 4 quarters of the hour, you have these readings. You have 50, 35, 30, and 45 tags are detected respectively. Okay, so you have a problem because there is no calculate the, not a problem, but you have different number of readings. So calculate the average of the traffic here. So of course it is over 1 hour. So for ATTV, the formula is this. It's only the number of interval is n, and TI is the number of tags counted during an interval denoted by i's, and you have to do the sum of each interval. Very easy. So what is the traffic, the ATTV for this case? Very easy. we have to sum the readings we have at each interval, and then divided it by the number of interval. So what is the ITTV for this? Just if you can give me the answer. How you calculated it, Mohammed? Do not take into account the 15 minutes. 15 minutes is only used, okay, divided by the number of intervals, Mohammed, not the number of minutes. The number of intervals, because you consider 1 hour. So you have to sum the readings over. Yes, this is so you divide by 4, because you have 4 quarters and 4 intervals, yeah, in 1 hour. Maybe maybe you can use yes, it's 40 because it's average here. So 40 by each quarter. This is what we are. So this is 50 plus 35 plus 30 plus 45, and it is given the total divided by the number of intervals, which is 4. Okay, this will give you 40, and 40 readings at each quarter by 15 minutes. At each 15 minutes, I can write it like this: 40 readings per each 15 minutes. Okay, so the ATTV, and you can perform this measure, and then you can compare, for example, yesterday and today, and this will give you an idea about the load of the Here you have another case. You have this table, you have the count between 9 and 9, and this is the hour: 50, 55, 60, 55, and 31, between 9 to 10 on 1 hour. You have these values, so you can calculate the ATTV very easily. And another information: during this time, the total number of read errors is 50, and the total number of successful reads is 600. So calculate the ATTV exactly at the same with the same method as we said here, but the interval is different here for this case. So could you please calculate the ATTV first? And Okay. Yes. Yes, Huda, on 6. Yes, yes, yes. Very good. So you are good. You are good. Now calculate the RTR. So for the ATTV, it's okay. It's 46. So what we do, we sum this intervals, 45, 50, 35, 60, 55 plus 31. And then we divide this by the number of intervals that are 6. And this will give you the which is the ATTV, which is 46. And then by 10 minutes, each 10 minutes you have 46 readings. This is the load. So if you compare this load with the previous one, this network is more loaded than the other. This one is 40 by per each 15 minutes. This is 46 per 10 minutes. This will give you an idea about the load of the network. Now RTR, please. RTR, it's calculated this way, and and this is the ratio. It's the number of error on the error plus the successful read. Very easy to calculate too. So anyone can give me the value of RTR for this case? So for your exam, for this exam, for your final exam, maybe you have to choose a correct answer for cases like that. Okay, so RETR 00. How you did it, Mohammed? How you did it? Just give me the ratio. Yes, yes, yes. Mohammed, it's yes. Huda, yes. We have the errors. The number of errors is 50. Okay, 50, and then we divide by the total of the readings. Successful 650. So it gives you 650, and you have this ratio. So you have 50 errors divided by 50 plus 600. 600 divide. So it's the ratio is for RETR. It's and you can calculate it. It's 1 on 30. Yes, without unit for that. It could be error by readings or error by readings, but it's without unit. Yes. Okay, Hina, if you do this calculus, I don't know, it will give you the value. Okay. Good. Is it correct with you? So just remember these 3 formulas. You will have it. You will have them in that. Not very difficult. So you have to diagnose the failed reads because you have to identify the improperly tagged items, You have to check the reader functionality, the troubleshooting common antenna issues. So when you have this, the diagnosis could be due, the failures could be due to the firmware upgrades, because for the readers, and this is like, for example, like operating systems. So after a certain period, you can have the upgrade. You have to upgrade the firmware, especially when you change the tags or something like that. Maybe you have to change the firmware in order to manage correctly the tags. So you have to respect the replacement procedure of the equipment. Maybe you are using incompatible equipment, so you have to check this too. So you have to match the antenna gain and the transmission line loss. So remember the adaptation. Input impedance and the characteristic impedance should be equal. Remember that when you connect the impedance, you can buy a cable and be sure that it is 50 ohm. Okay, so maybe this condition to respect. Okay, input impedance to this is for the cable, and when you buy the cable, usually you have 50 ohm, but you can buy a cable which is not 50 ohm. It's not, and this is a problem, and you will lose the energy and so on. So matching the antenna and the transmission line and the connectors also should be good. Detuning, mutual inductance and RFID tags. Detuning when you put the tags close to each other. So this is what we call detuning, because when you put the tags close to each other, you will create a magnetic field, and this is what we call mutual inductance in the RFID tags when they are in close proximity to each other. So avoid this by respecting the rules of distance, the minimum distance between tags. The presence of metal and different dielectric mediums near the tag. So it's very important. A shift in the resonance frequency from the operating frequency. So maybe sometimes you define a frequency, operating frequency, and then maybe it's not the real frequency on which the reader is working. So you have to be sure that this is the right frequency that correspond to the resonance frequency of the tags. So corresponding the tuned frequency of the reader and the real frequency. So maybe sometimes it's better to change the channels and to have for a reason or to another reason you have to you have a frequency that is better for working than another. Even if there is no rational reason, you have to check this. So if you are using multiple readers, sometimes it's better to have what we call a reader network controller, an interface between the server and the readers. If you have many tags, many readers, maybe a controller for the readers is good in order to facilitate the management of the reader networks. And there is a protocol in this controller which is called the SLRRP, which is known today as the LLRP, the reader protocol, to manage the huge number of readers. And the interface could be on the TCP/IP networks. So it's known, it's easy to use, it's flexible, and so on. So this is when you have a big number of readers to manage. So it facilitates the management of a great number of RFID readers within enterprises using the RNC, define the rules used by the reader to communicate to RNC the configuration data, status control, and so on. The AIR protocol, manage this, the time slot to write into tag, because in this configuration, if you have a thousand of data, you have to manage this by giving the slot time for communication and so on. And this is done by the controller. And it uses the TCP/IP network, which is very easy because this network is already here, already present. The protection, the shield, of course, the shield's Faraday cage if necessary, avoid the vibrations and shocks, avoid the extreme temperatures, and avoid the operational mistakes. So this is common sense actions for the network protections. So like for the network, I have questions, I think 2 days ago, 3 days ago about the hacking. Yes, there is exactly the same problems and vulnerabilities, and I gave you a lecture about that. So please read the paper and read the article and then summarize it about the vulnerabilities and RFID. So RFID is a network, and you have a radio frequency waves, and then you cannot avoid the fact that you can have hijacking and hackers and of the data. So you have the denial of service, very known way of hacking a system. So here it's using multiple tags, or especially design tags that are used to overwhelm the reader's capacity to differentiate tags. Okay, so you disturb the system, and you prevent him to make good readings. You have the eavesdropping or sniffing or transmission between the tag and the reader. There is a hacker in the middle, and and the data which is transmitted is intercepted. So by using another reader or an antenna. Okay. So this is to intercept the data. The spoofing is also known in the network, computer network, duplicating the tag data and transmitting it to the reader, to a reader to mimic a legitimate source. So without the knowledge of the owner of the tag, and the spoofing is known also on the computer network. The skimming data is the unauthorized access of reading of tag data. Data is read directly from the tag without the acknowledgement of the tag holder. So please read there is a good paper I gave you. So please read it to complement this issue about security, and very similar to computer security to network security. So to prevent this, you have encryption protocol. You can encrypt your transmission, the data you transmitted. So exactly like if you encrypt messages that are sent from Wi-Fi over Wi-Fi facility. So authentication through the reader interface. So you use passwords, and as I showed you in the bank 00, you can use the password, and besides this, you can also add encryption to be sure that your data are protected. You can lock the tags and use only write once and read multiple. So to prevent that the hackers write onto your tags, and if you are sure that that your tags are used only, that you will not perform a writing once again. So better to use write once, so you can write your information, and then you know that it is not possible to write another time on these tags. It's better for to prevent the change and of information by another not authorized users. So, like by using firewall, you can make the readers invisible by by hiding the IP address. So exactly like the same measure you can done for the computer networks. Okay. In conclusion, so you have to do the best by using blueprints, information, gathering information, many visits to the site, discussion with the persons in charge of the IT and of the site, document everything, and to assess the information flow and business flow, and when the company is in full load, full charging, not in weekends and so on. So you have to observe, you have to see what are the networks present on site, the environment, the standard to follow, the applications. So you have to tune, to test, to synchronize, to manage the cable, to position and design the tags, to manage the equipment and the data with the middleware, and so on. It's not complicated, because the technology is not complicated, but it's you have to do it professionally and with by following the rules and so on. So this is the full content I intended to provide to you, hoping that this answer to your expectations. And then if you have comments, questions, and so on. So for the final exam, see avec your professor, Professor Naitali. He will do the exam for you. The exam is 50 questions, multiple choice, but only one correct answer, exactly like the quizzes we've done. And for 1 hour, 150 hour, I think. So for the date, so say with for the schedule, say with your professor Naitali. And if I expect to receive your summaries of the papers 2 weeks from now. Only 3 lectures that are on the platform. Yes, this is summaries, Lisa. For each paper, you have to do a summary. Okay, for each paper. So you have 2 weeks to do it, and then you do your final exam. There is a final exam. We did quizzes, and I think that with the lecture and the documents, you have enough to do with this content. Okay. Any other questions, comments? Feel free to send me an email. Okay, if you have any questions, maybe you do not remember it now, or you can. Okay, good. So I think that it's okay. So maybe I wish you good luck and for your studies, and hope that RFID is interested. You have been enjoyed your course. Okay, guys. Okay, so bye, and I wish you good luck. Bye. Okay, good, Mohammed. Okay. Okay, good. See you guys. Sixtus, do your lectures, huh? Because I know that you are not present, so do it. And if you have question, just send me an email. Okay, Sixtus? Okay, so see you. You can also ask your teammates. Okay, bye. Okay, disconnection.